Q7292. In an aircraft equipped with a fixed-pitch propeller and a float-type carburetor, the first indication of carburetor ice would most likely be A. A drop in oil temperature and cylinder head temperature. B. Engine roughness. C. Loss of RPM. The correct answer is C. In an aircraft with a float-type carburetor, the carburetor ice can develop when moisture in the air condenses and freezes within the carburetor, obstructing the proper flow of air and fuel mixture. This obstruction affects the engine's performance and can lead to a loss of power. When carburetor ice begins to form, it restricts the airflow and disrupts the fuel-air mixture, resulting in a decrease in the amount of air reaching the engine cylinders. With less air available for combustion, the engine's power output decreases, leading to a loss of RPM. A loss of RPM is often the first indication of carburetor ice in an aircraft equipped with a fixed-pitch propeller and a float-type carburetor. The engine may run rougher, and there could be a noticeable decrease in RPM, indicating that the ice is affecting the engine's performance. It is important for pilots to be attentive to any changes in engine RPM during flight, as a loss of RPM can be a warning sign that carburetor ice is present. Prompt action, such as applying carburetor heat or adjusting the mixture, should be taken to melt the ice and restore proper engine performance. Ignoring or neglecting the early signs of carburetor icing can lead to further power loss, rough-running engine, and potential engine failure if not addressed promptly. 6661. The low temperature that causes carburetor ice in an engine equipped with a float-type carburetor is normally the result of the A. Compression of air at the carburetor venturi. B. Freezing temperature of the air entering the carburetor. C. Vaporization of fuel and expansion of air in the carburetor. The correct answer is C. Carburetor ice forms when moisture in the air condenses and freezes within the carburetor, obstructing the proper flow of air and fuel mixture. The formation of carburetor ice is typically related to the temperature changes that occurred during the fuel vaporization process and the expansion of air in the carburetor. The low temperature is the result of the vaporization of fuel and expansion of air in the carburetor. When fuel is vaporized in the carburetor, it absorbs heat from the surrounding environment, causing a drop in temperature. This temperature reduction is further accentuated by the expansion of air as it mixes with the vaporized fuel. As the fuel vaporizes and the air expands, the temperature inside the carburetor decreases significantly, especially when the outside air is humid. This temperature drop creates the ideal conditions for the moisture in the air to condense and freeze, leading to carburetor icing. It's important for pilots to be aware of these temperature-related factors and be vigilant about the potential for carburetor icing. Proper use of carburetor heat, maintaining the correct fuel-to-air mixture, and monitoring the environmental conditions can help prevent the formation of carburetor ice and ensure safe operation of the aircraft. 6662. Concerning carburetor icing, which statement is true? A. The first indication of carburetor icing in an aircraft equipped with a fixed-pitch propeller is a decrease in manifold pressure. B. Carburetor icing will form in a carburetor whenever the ambient temperature is below freezing with a reduced or closed throttle setting. C. Carburetor icing would most likely form when the air temperature is between -7 degrees C and 21 degrees C and visible moisture or high humidity is present. The correct answer is C. Carburetor icing occurs when moisture in the air passing through the carburetor condenses and freezes, obstructing the proper flow of air and fuel mixture. The formation of carburetor ice is influenced by specific atmospheric conditions. Carburetor icing would most likely form when the air temperature is between -7 degrees Celsius and 21 degrees Celsius, which covers a range from slightly below freezing to moderate temperatures. This temperature range is considered favorable for carburetor icing because it includes temperatures where ice can form. 6652. Fuel/air ratio is the ratio between the A. Volume of fuel and volume of air entering the cylinder. B. weight of fuel and weight of air entering the cylinder. C. Weight of fuel and weight of air entering the carburetor. The correct answer is B. The fuel/air ratio refers to the proportion of fuel to air in the combustion mixture that enters the engine's cylinders. It is a critical factor in determining the efficiency and power output of the engine. The fuel/air ratio is the ratio between the weight of fuel and the weight of air entering the cylinder. This is the accurate definition of the fuel/air ratio. The weight of fuel and the weight of air are considered because weight is directly related to the mass of the substances involved. The weight of the fuel and air entering the cylinder is essential for ensuring the proper combustion process. The ratio between these weights determines the stoichiometric mixture, which is the ideal ratio at which the fuel and air combine for complete and efficient combustion. By adjusting the fuel/air ratio, pilots and engine operators can optimize the engine's performance and efficiency. A mixture that is too rich, excess fuel, or too lean, insufficient fuel, can result in inefficient combustion, reduced power, increased fuel consumption, and potential engine damage. It's worth noting that the fuel/air ratio can be controlled by various means, including carburetors, fuel injectors, and engine control systems, depending on the type of engine. Precise control and management of the fuel/air ratio are vital for the safe and efficient operation of internal combustion engines. 6648. As flight altitude increases, what will occur if no leaning is made with the mixture control? A. The volume of air entering the carburetor decreases and the amount of fuel decreases. B. The density of air entering the carburetor decreases and the amount of fuel increases. C. The density of air entering the carburetor decreases and the amount of fuel remains constant. The correct answer is C. When an aircraft climbs to higher altitudes, the atmospheric pressure decreases. This decrease in pressure affects the density of the air, which refers to the mass of air per unit volume. As the density of the air decreases, the amount of oxygen available for combustion also decreases. In a normally aspirated carbureted engine, the mixture control determines the ratio of fuel to air for proper combustion. If no leaning is made with the mixture controlled during a climb, the mixture remains constant, assuming a fixed setting. As the aircraft ascends and the air density decreases, the carburetor continues to deliver the same amount of fuel, which is appropriate for the denser air at lower altitudes. However, since the density of the air is decreasing with altitude, the fuel-to-air ratio becomes richer, as there is less air available for combustion. This can lead to an overly rich mixture, which affects engine performance and efficiency. To maintain the proper fuel-to-air ratio and optimize engine performance at higher altitudes, pilots need to lean the mixture by reducing the amount of fuel supplied to the engine. By leaning the mixture, they compensate for the decrease in air density and ensure the correct balance between fuel and air for efficient combustion. It's important for pilots to be familiar with the proper leaning techniques recommended by the aircraft manufacturer or specific operating procedures to ensure safe and efficient engine operation at different altitudes.